In this video, we'll discuss the factors that influence oil pressure, we'll describe the sensors and valves that support the lubrication tree, and we'll go through a real-world diagnosis and repair of an engine presenting with low oil pressure warnings on the dash. Good morning, here we are for a cold start on a 2000 Suburban. Main complaint is low oil pressure on cold startup, one time only every day. And so I've set up the scan tool. Unfortunately, I'm not seeing a data PID for oil pressure, but in any case, I'm going to fire up the engine. We'll see how long it takes for this gauge here to come up. Here we go. Still no oil pressure. There's a blip. And then I'm getting a check engine oil signal right there. Still almost nothing. And finally we come up, and that light has gone out now. So that's a real slow top up, and I'm not sure why. The plan today is to change the oil filter, and hope it's the anti-reflux filter inside the filter, the reflux valve inside the filter. I don't think that's the cause, but I'm going to do that now just to rule that out as a possibility. This is 530 natural oil. Okay, let's pause for a minute and talk about what could do this. The oil pump is on the left, directly driven by the crankshaft. When the pump is spinning, it applies vacuum to this tube, which extends below the level of the oil in the pan to suck up oil like a straw. The two vulnerable points of that tube are the screen, which can clog up, and an O-ring seal right here that can dry and crack. Here's a view of that O-ring taken by my friend Oz Mechanic on YouTube. I'll embed a link to his video. Like any straw, if air can leak past the O-ring, the vacuum is broken and your pump will drop smaller volumes of frothy oil, and oil pressure will sag. People will typically present with noisy lifters on startup, sometimes in new engines, and it was common enough for GM to issue a TSB. Here's more detail of the pump. It delivers a fixed volume of oil with each rotation. So as crankshaft rotation increases, there's an automatic delivery of more volume to meet higher needs. Analogous to Ohm's law, oil pressure is related to the product of flow volume and end resistance. So it should be no surprise that as old engines age, they get sagging oil pressure as bearing clearance increases, often improved by adding a higher viscosity oil. Oil coming from the pump goes into the oil filter, where you'll find a one-way valve designed to prevent backwards siphoning of the oil from the tubing after the engine shuts off. So if that valve fails, you may get a longer time on cold starts before adequate oil pressure is seen by the sensor. When you cut into an oil filter, you'll discover that valve is just a small sheet of plastic that works like a flap valve. The oil pressure sensor lives up here. The next time you change your oil, think about the two valves hidden inside the oil filter. The first is the anti-drainback valve here. It's just a silicone dam that's flexible enough to allow dirty oil coming from the pump to push it up and over. The silicone directs the dirty oil to the outside of the filter, and then from there, oil is forced through the paper filter to the clean inside, where it's swept to the engine. But what if the filter gets so clogged up that oil can't get through? You need some kind of an emergency bypass, a relief valve that allows dirty oil through if pressures are too high. That valve's right here. It's a spring-loaded gate. It takes quite a bit of pressure to open it. You can see it on the inside there as well. For those of you who want more detail, here's a useful summary of the valves present in the oil delivery chain. These days, almost all oil filters will have the anti-drainback valve that I'm referring to here. Only a minority will have the so-called anti-siphon valve. Generally speaking, siphoning can happen in either direction, but the term anti-siphon valve as applied to oil filters specifically refers to forward siphoning of clean oil, mostly by vehicles equipped with a turbo. So here's a list of possible causes. We've ruled out number one because replacing the filter and oil made no difference. I'd like to explore that oil pan intake tube a little more, but especially in a four-wheel drive vehicle, that job takes hours. You need to drop the front axle a couple of inches to get enough clearance to slide out the pan. With that in mind, I've decided to have a closer look at the oil pressure sensor first. These two bolts are 8mm. It's going to be hard to get a camera in here, but let me just walk you through as to where we're at. We're deep in here. And that's the end of it right there is an electrical connector. And when I reach in there, I can feel the tab to lift it off. You just put your finger around the back and then lift, and then we're going to wiggle and pull, and we're going to get that electrical connector off. The other thing I noticed here, there's a whole lot of oil in here. That connector came off really easily, and what I noticed right away is it's really wet with oil back in there. Let's see if I can show you what I'm talking about here. So there's the connector, and this is the tab that I was taking off, and I reached behind and just pulled that tab back. And you can see how wet it is, and seems like there's liquid right in the connector itself. Okay, this is coming easily. I'm going to move the camera out of the way and take it completely out. So this is what I used to get it out. Little universal joint to a 1 1/16 socket. This came in an oxygen sensor socket kit. And here's the sensor here, and you can see it's all oily. Oil right in the connector as well, which is telling. This is more of a plumbing borescope than it is a scope for automotives, but in any case, I'll just have you look at what I've got here. Yeah, there it is right there. You can see that's our hole right there. I'm looking for a screen. Some of the newer models have a screen. I don't know if this one does. I'm looking right down. What I do notice is all that oil around there. It looks like it's been leaking from the sensor itself, and it was really easy to get off. Okay, so I have this oil pressure sensor kit, and I was hoping to independently prove that the sensor is bad. But unfortunately, the closest adapter I have, which looks like a 3/8, is just a little bit too big, a hair too big. Yeah, it took a few days for these to come in. I went to the dealer to get this. I got a genuine part. That's my AC Delco part number on the top, and then the GM partner on the bottom. And it basically is the same. Made in Mexico. Let's put it on. Okay, first moment of truth. I've just changed the oil, so there's going to be a bit of a sag with that, but let's just see what happens.
You know, I could go into a community practices is to have...
Oh, look at that, how quick that came up. And it's up higher than it was before. Is funner a word? I think it should be. There's nothing funner than taking these things apart to see what's inside. Let's do it. First, I'm going to take the end off so that I can use that as an adapter later if I need to at some point in the future. Look at that. See, it's all full of oil. Look at that oil draining out. It's like a CSI. Now you look at this thing here, and you see how that thing can move. So pressure in the hole there pushes up on this and allows this little switch to move. See that? There's no hole in this end. So this whole thing slides up and down. Okay, here's the seal. I wonder if this is the part that went bad. And then we've got this spring. Pull the spring out. And then this mechanism here. I decided to cut it around this way. I'm trying not to destroy evidence so that we'll actually understand how it works when we get it apart. Okay, so as usual, when you take these things apart, they're elegantly simple. And I think this is actually a variable resistor. It's a single wire sensor. And you've got this probe that when the pressure was pushed in and out, this probe rotates. It rotated on this axis right here. And I think that this contact makes contact with the coil. I'm not sure which side, this side or this side. Makes contact with this. I called it a coil. It's a length of wire. And it'll have a certain resistance to it. And depending on whether it's rotated one way or the other, the resistance will increase or decrease. So it really is a true pressure sensor. Okay, it's all working great now. The strange thing about this story from my perspective is the way oil pressure was only low once a day, first thing in the morning. And if I had to restart the car later in the day, oil pressure came up right away. It was almost as though the leaking sensor needed to be recharged with oil before it would start to work properly. In any case, it's all done now. Now, the other tip I have for you is that don't go to the dealer. I made the mistake of going to the dealer in part because I couldn't find a new part number, a substitute part number. When I did find the correct part number, I went online and I found that Amazon was offering it for $50, an OEM part for $50, whereas the dealer charged me $150. My burn. In any case, thanks for watching.